This is John Black, Super Chemist, here to talk about sodium silica gel. Now, in the last video, I went over what type of silica gel you need, pore sizes, etc., how to prepare it before you do this reaction. You know, you want to degas it, etc. You may want to calcinate it. That's all in the last video. This one is about the sodium silica gel, and this material comes in 4 phases or stages. And each stage can be made from the previous stage. So if you have stage 0, you can make stage 1 from it. If you have stage 2, you can make stage 3 from it. You know what I mean? Let's go over stage 0 first, right? Stage 0 still reacts with O2, or dry O2. It's made under isothermal conditions. And I didn't look it up, but isothermal, I'm guessing, means no temperature change. It's a constant temperature. It's made under inert atmosphere like nitrogen or argon or even a vacuum. I'll probably get argon. Argon you can get at the welding store where they sell torches and stuff for like acetylene. And the metal should have a melting point within 15 degrees of room temperature. Because you don't heat this reaction to make stage 0, right? You can heat it up 15 degrees above room temperature. If you got to heat it more than that to get the metal liquid, then you can't use that metal, okay? And that's why you can't use sodium to make stage 0. You need something like cesium or NaC, an alloy of sodium and potassium. You need something that's liquid, or something like cesium that will be liquid if you only heat it 15 degrees above room temp. It's still pyrophoric, but it's less explosive than sodium metal, okay? It can ignite in air, but it's only being absorbed by the silica, okay? It's not changing chemically, right? And basically, all you do is you add your prepared silica gel and your metal that's a liquid. If it's not a liquid, you just, you can only raise it up 15 degrees. If it's not a liquid by then you can't do it. Have your inert atmosphere or vacuum and just agitate it. Agitate it a lot because you want the metal to get sucked up by the silica gel. Once it does, it's all sucked up. You'll have a free-flowing black powder, okay, and that's how you'll know you're done. If it's all free-flowing black powder and there's no liquid, it may take several hours to do this, but you want to do a lot of agitation, get your flask by the neck and stir it up a lot. I don't really care about stage 0. It's like I said, it's still pyrophoric. It's not that great. And stage 1 is what you want, especially for the reaction I want to do. Really, for any reaction, I think stage 1 would be the best, or at least most of them. It does not react with dry O2. This stuff, actually, once you make it, it's pretty indefinite on its stability of being, where you can just let it sit around for a while. It's made under exothermic conditions. It will produce heat, and you need to add heat, right? Now, if you have stage 0, all you have to do is take stage 0 under an inert atmosphere and heat it up to 140 to 150 degrees, slowly agitating it once in a while, and leave it on that heat overnight. But if you don't have stage 0, like I'm making mine from sodium, you can't make stage 0 with sodium, right? So what I'm going to do is I'm going to take the sodium. It melts around 100 degrees. I think it's like 97 degrees or something like that. So I'm going to add the sodium, add the prepared silica gel, get my inert atmosphere, and then I'm going to heat it up slowly until the metal melts. I want a viscosity that's low enough so that, it's very free flowing, not like a syrup. I want a liquid, like, like water. I want it to be able to, for the silica gel to absorb the metal. Now, until it absorbs all the metal, you need to leave it at 100 degrees C. You know what I mean? Agitate it a lot, a lot. And once you have your free-flowing black powder, you know it's like stage 0, right? At that time, you want to take up the heat slowly, to, take an hour to 3 hours to raise it up to 140 to 150 C, right? 150 C, leave it overnight. Agitate it once in a while, you know what I mean, overnight. You don't have to agitate it as much as you were trying to get the silica gel to absorb it, but you need to agitate it once in a while, make sure things are going right. Now at this point, at the 100 degrees, you're just basically trying to get the silica gel to absorb the sodium like it would with water. It doesn't change it chemically, it just absorbs it. But once we heat it to 150 C, now we're actually trying to do a reaction, okay? And the reaction at sodium, it's a electron donator. It donates to the silicon dioxide crystalline lattice. It donates an electron and becomes positive, right? And basically, you're creating nanoparticles of Na4Si4, all right? So this is actually what reacts, like when I try to make my alcohol from esters and reduce it, this is my reducer now. This is my reducing agent, not sodium. And that's why it's safer, okay? I don't know if it's pyrophoric still. If it is, it's less pyrophoric than stage 0, just like stage 0 is less pyrophoric than the actual metal itself, okay? You're getting better with, exploding. This actually is, it's pretty inert, stable, I should say, indefinitely, keep it in dry air, you know what I mean? If you have it in moisture, that's not good. But anyways, this stage 1 is actually the best for reductions. It's better than 0, it's better than 2, and it's better than 3. It's the best. You can't do better, and that's why I kind of stopped with this, but I'm going to go over the other stages, even though I don't care about them. So this is the best. So what about stage 2 and 3? Now, stage 2, if you have stage 1 material, you just heat it up to 215 to 400 C, right? So let's say it's me doing this. So I brought the metal to a melt. I waited for it to be absorbed at 100 C. And I took it up to 150, 140 C. And if I wanted to make stage 2, I wouldn't leave it overnight. I would continue to heat it up to 215 to 400 C, okay, and leave it overnight. And when I say heat it up, you got to do this stuff slowly, like 1 to 3 hours to get it to the 150 C, from 1 to 3 hours to get it. Every 50 degrees you raise it, you want to take 1 to 3 hours to do it, you know what I mean? Once you get it to 400 C, you leave it overnight. And remember, agitate it once in a while, you know what I mean? And the thing about this stage 2 is it's the worst of all 4 stages for reducing. Its reducing ability sucks, okay? So let's move on to stage 3. Let's say you wanted to get it to stage 3. Once you got stage 2 to 400, you wouldn't leave it overnight. You would continue to heat the material above 400 C, preferably 500 C. Now remember, you increase temperature gradually over several hours. And I don't know, it doesn't say leave it overnight, but I would guess that you would want to do this, a leave it overnight kind of thing. But this is, not as good as stage 1. So I want stage 1. Okay, so I just want to go over a couple facts about the sodium silica gel. You don't have to use sodium. But you can use any of the group 1 metals. Lithium, I think you need ultrasound. It won't work without ultrasound. I'm guessing on this lithium. I wouldn't use the lithium. Sodium is the best metal, though. Sodium is the best, then potassium and NaC. Okay, these are the second best. All right. Always remember, you want the viscosity of the metal should be low enough to be absorbed by the silica gel. You can't have it being syrupy. You know what I mean? You want nice watery. And if you make hydrogen from any of these stages, you should get a 95% yield. If you use the stage 1 and you use it to reduce esters to alcohols, like I want to do to make benzyl alcohol, then you should get up to a 99% yield. Yes, I said up to a 99% yield over a 5-minute period. The reaction should take 5 minutes, although after you add the alcohol, you probably should wait another 30 minutes just to make sure. The amount of sodium absorbed by the silica gel depends on pore size and pore density. Okay. Now we said we wanted a pore size of 150 angstroms. Of course, you can use anything from 50 to 150. I mean, anything from 50 to 1,000 angstroms. So it all depends on that. But you do want to have, like, let's see where it says, stage 1, 2, and 3 never absorb more than 40% metal by weight. Okay. Stage 0, never more than 50% by weight. And if you want the best, you want it to be between 30 and 40%. Me, I'm going to go with 33 because it's a third. It's a nice even. I know it's not really even, but in my OCD brain, a third is the most even number that I could do here. So 33%. That means, whatever I have in metal, let's say I have 10 grams of metal, that means I need 20 grams of silica gel, right? So that 1/3 would be metal and 2/3 would be, twice as much silica gel. 2/3, 1/3, it's twice as much. So you got 1 gram of metal, you need 2 grams of silica gel. 2 grams of metal, you need 4 grams of silica gel. Because what happens if you use more than what I'm telling you to use in metal, basically it doesn't react with the crystalline lattice of the silicon dioxide. It won't react. You'll just have pure metal inside there. And that defeats the whole purpose. You're trying to turn the metal into this sodium silica, you know what I mean? So that it's less pyrophoric, it's more safer, you know what I mean? And if you try to do more than 30%, you're just defeating the purpose of doing this. You might as well just use pure sodium. All stages of this sodium silica gel material are free-flowing black powders. Okay, so once you have stage 0 or stage 1, it's always going to be a black. If it's not a free-flowing black powder, then it's not any of these things. It's not stage 0, 1, 2, or 3. You want silica gel. You want a 150 angstrom pore size, 30-60 mesh, no water indicators. You want to degas it and dry it, and if you're really hardcore about it, you'll want to do a calcination. If not, you're ready, you're prepared to use your silica gel. Then your sodium, you want to get it in an inert atmosphere, get the silica gel and the sodium together, heat them up very, 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 very slowly till it melts. Which would be about 100 degrees Celsius, maybe a little bit more. You want the viscosity to be low enough where it's really free-flowing so that it can be absorbed by the silica gel, right? Then once and agitate it a lot to get it to absorb all the liquid, and there's no liquid metal left, you know that it absorbed all the metal, right? So now you're ready to heat it slowly. Take, 1 to 3 hours to get it up to 150 C, okay? Leave it overnight, agitate it once in a while, you know what I mean? And then you're done.